Okay. Again, I'm sorry. Okay, let me say again. We're starting. That means stop talking. We're starting on counting today. And counting is kind of a misnomer. It's not exactly counting 1, 2, 3, 4, but it is using the numbers a whole lot more than you've been using them. Write down these definitions right here or make a note. This is page 175. Permutations and combinations. Now, there'll be quite a few questions on the test pertaining to permutations and combinations. This is 4.6. It used to be 4.7, but they changed it. So, that's what we're going to cover. A permutation is an arrangement of different sequences, and the permutation has order. That's the main thing that you have to remember. Permutations have some kind of order. A combination does not have order. Now, permutations and combinations all use a formula that has that in it. And that is the mathematical symbol for factorial. Factorial. Now, I don't know how many of you have seen factorial before. I don't know how many of you have had this class before. So, you know, I have to assume that there's people in here that's never seen it before. So, factorial is a way of counting that uses all the numbers from the starting number to 1 multiplying in sequence. That's a Hubertism definition. In other words, if I have 3 factorial, that means I'm going to multiply 3 times 2 times 1. 3 times 2 times 1 is 6. If I have 4 factorial, then that's 4 times 3 times 2 times 1. Now, you can do this 2 different ways. You can either multiply by hand, 4 times 3 times 2 times 1, or you can multiply 4 times what? 6, which is 3 factorial times 4, 4 times 6, and that gives you what? 24. Or you can say 4 times 3 is 12, 12 times 2 is 24, 24 times 1 is 24. Now, anytime you're dealing with combinations or permutations, factorial will be used. There's other ways to use factorial, such as how much, if you have a 5-letter word, back it up. There you go. And I'll do one more. 5 factorial. What would 5 factorial be? 120? Well, what's 5 times 24? 120. So 5 factorial is 120. 6 factorial would be 720. And so on. Why don't we use 0 in factorial? Because it would cancel everything out. Wouldn't be any sense in doing factorial. All right. You got it now?
Yes, sir.
All right. There are one way of using factorial is with a fundamental counting rule, which is like this one right here. Number of ways two events can occur, and that way you multiply m times n. In other words, you have two instances happening. What is the probability of both of them occurring? And that's, you just multiply the two together. For a 2-character code consisting of a letter followed by a digit, the number of different possible codes is 26 times 10. Why is it 26 times 10? Well, you have how many letters in the alphabet? And how many numbers from 0 to 9? 10. So you multiply 26 times 10. The fact.
Where in the word problem did you get that?
Right here. For a 2-character code consisting of a letter followed by a digit. 2-character code. Nothing spectacular. But what if you have a 5-character code? Then you'd use the factorial rule. The maybe that second one right there. If you had a 5 number, I don't know, 5 number keypad on a alarm system, then you would do 5 factorial. 5 times 4 times 3 times 2 times 1. Yes, ma'am. Can what? Yes, right here, number 3. There's the formula for permutations. Here are the 4 ways to use factorial. You'll just have to look. I can't get it all on one. Wait a minute. Hold on. Maybe I can. There you go. There's the 4 or 5 ways on page 176. The fundamental counting rule, which means you have 2 numbers. The factorial rule, which means like an alarm system or a combination lock or anything like that. Permutation rule means order. And the combination rule is no order. Now this is when the examples will help you more than the definitions. It will help you a whole lot more seeing the examples than actually looking at the definitions. Now, this is the time that I will tell you to use your calculator, because the combinations and permutations are in your calculator, and they are N, P, R, and N, C, R. And I think they're under math. I don't know if they're under math or stat or what. You'll just have to find them. You'll see them. I mean, under stat somewhere, or probability. Somebody tell me what button they're under.
Yeah,
Math and probability. So go to math, then probability, and you'll see them. Those 2 right there. Those are the 2 we're going to be using. Now, any other type of probability problem, you're going to use, just by hand, factorial or whatever. Factorial is not hard to use. Factorial key, isn't it above the 7? Somewhere above the 7 or 8? I don't know where it is, but it's above one of your keys. Anybody see it? Or you might have to go under math and go under probability. I think it's in that list. Is it? Okay. So your probability key gives you those 3. If you do not have a TI-83, or you haven't put it on your phone or whatever, you can go with the Excel spreadsheet. The Excel spreadsheet, I think you call it permute. And then combine, COMBIN. Those 2 will, and then you type in parentheses, and you type in your N and your P. Your R. And it will, and close parentheses, and it'll calculate your combination or your permutation. There was one other thing I wanted to tell you. Now, if you want to do it by hand, knock yourself out, but it's a pain. I mean, it's just you have to put everything in memory. You have to put this in memory, then you have to put this in memory, and then you have to take memory divided by memory, and you can do that. Either way, you get the same answer. So let's go ahead and look at a couple of examples. And I will pull most of the examples that I'll put on a test.
Are we going to use the reverse permutation rule?
No, I'll hold on a minute. I'm glad that's what I meant to say. The one that I will use is number 3. That's the one I use. Okay, so I'm not going to try not to use number 4. Okay. I find one that's real simple to understand. All right, example 3. In a horse race, a bet on an exacta is won by correctly selecting the horses that finished first, second. Okay, and you must select those 2 horses in the correct order. Now, what does order tell you? Permutation. Okay, the 36 blah 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 had a field of 20 horses. What is N? N is always your big number. Write that down. N is always going to be the number of the population in combinations and permutations. So, what is N? 20. Had a field, in other words, had 20 horses racing in it. If a bettor randomly selects 2 of those horses, hold on. Well, how did that happen? Go back down. Okay. If a bettor randomly selects 2 of those horses for an exact bet, what is the probability? Okay, I didn't read that. What is the probability of winning by selecting Super Saver and blah 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 to finish second, as they did? Do all of the blah blah blah. So you would type in N would be 20, and then it'd be permutation, and then R would be what? 2. Now, if you did the formula, you'd do this. And you'd have to put this in parentheses, then divide by parentheses 20 minus 2, close parentheses, factorial, and it would spit out your answer. Or you could just type in 20, then math, probability, NPR, then after it puts it on your screen, then type 2, and then hit enter. So let's pull up our handy dandy virtual calculator for anybody that needs it. And make sure it's on. Type in 20, math, probability, NPR, and 2, and enter. That simple. And I'll put a few of these on the test. Your test is going to consist of 4.2, 4.3, 4.4, and 4.6. 80% of your test. And I do break up Chapter 4 and Chapter 5, so we'll take Chapter 5 later. Capiche? So, there's 380 different combinations or permutations of the field of 20. And that's how you use the permutation rule. Now we'll get into the lottery, and that's when we have a little fun with it, you know, because it's interesting to know how they get the lottery odds. Well, here's one right here. In Pennsylvania, match 6 lotto, winning the jackpot requires that you select 6 different numbers from 1 to 49. 6 different numbers from 1 to 49. Now write that down. 6 different numbers from 1 to 49. And the same 6 numbers must be drawn in the lottery. The winning numbers can be drawn in any order. So order does not make a difference. So what does that say? Combination. Find the probability of winning the jackpot with 1 ticket being purchased. You need to highlight that 1 ticket, because a lot of people get this wrong because of that 1 ticket. And if you've had probability before, you know what I'm talking about. Or you forgot, one of the two. So what is N? 49. What is R? 6. And that's not the problem. Go ahead and do it. Pull up your handy dandy virtual calculator, and that'd be 49. We did say 49, didn't we? Math, probability, NCR, and 6. And you got a 1 in 14 million chance. Where'd the 1 come from? If you don't buy a ticket, you can't what? You can't win. You can't have a chance to win. And the problem does put that in the question right here. Find the probability of winning the jackpot when 1 ticket is purchased. If you don't put that 1 in your answer, will you get it correct? No, you will not. And there's not a thing I can do about it because it's wrong. It's just like the difference between $100 in your bank account and negative $100 in your bank account. Is it the same? No, because you can write checks on one of them. You can't write checks on the other. So there is a difference between 14 million and 1 in 14 million. There's a whole lot of difference. Capiche? Do you understand? All right. And that's the answer right there. And then they tell you that that's not, here's the answer. This is part of the answer, and you would put 1 over it because you have to buy a ticket in order to win. Now we're going to get to the lottery, the South Carolina lottery, in just a minute, and we're going to talk about it. And I'll go ahead and we'll find one of those. Well, I don't know how the lottery. Let's go to pull up the lottery, because I don't play the lottery that much. I only play it whenever it gets above 100 million. I figured I could use 100 million or above. So no, I'd play it very sporadically. Let's pull up Google, and let's pull up. It's got like a very long address, don't it? www.South Carolina Education Lottery or something like that. I can't do anything. Education Lottery.com or something like that. Well, that's not it. Did I? Well, it don't even have it. Let's see where. No, forget it. South Carolina Education Lottery. There we go. All right. Now, how to play. Let's go to where there's somewhere on here how to play. Y'all okay? Did y'all take y'all's medicine this morning? Okay, well, Need to. All right, how to play. Here we go. All right, this is a test question, so you might want to write it down. There's how to play. Select 5 different numbers from 1 to 59. And then select one number from 1 to 35. Now, my question is this. What is the probability of hitting all 5 numbers and, capital A and D, and the one number, the Powerball? And the word that I used between those two is what? And. What's that mean? I don't know. And. Dang old 3, 4, somewhere in there. Huh? No, it's not in order. Yeah, it's not in order. One to 59 and 1 to 35, right? Yep. All right. So, 1 to 59, and that's 5 numbers, right? And 1 to what, 35? And that's 1 number. So, we know it's going to be a combination, so that would be 59 combination of 5 multiplied by 35 combination of 1. Huh? Well, yeah, you're going to multiply these two, yes. So we take our handy dandy calculator. And let's type in second function entry and go back and put a 5 there and a 5 here. And I'm going to put that in storage. I'm going to put stove, like you're going to run down to the stove. And that is alpha, we'll call that alpha A. Now let's do the second one. That would be 35, second function entry, and back up and do 35 and 1 gives you 35, and multiply that by alpha A. Can't find A, there it is. And that gives you a BA number. Alright, so let's take that number and let's say we buy 1 ticket. Sorry, I don't know what happened. Oh, it went away. I know what happened. Okay. I was on the calculator. There we go. Let me get my calculator back. And that will be, if I buy 1 ticket, 1 over 17 million, no, it's 175 million, 223, 510. 175, 223, 510. Now somebody calculate that, or I'll calculate it because y'all will give me 5 different answers to set me up. 1 divided by inverse answer, I get 5.706. 5.707. 5.707 times 10 to the negative 9. Is that what it was? Yeah. Y'all won't believe this, but I was teaching this class about 2 or 3 semesters ago. and we were doing this section, and it was a class like this where there was a lot of high school students, and this girl kept getting that answer right here. And she keeps saying, I keep getting the wrong answer. I keep getting the wrong answer. And I said, what are you getting? She said, it's got a letter in it. I said, I went and looked at it, and it was that. We had to explain to her about scientific notation.
Wait.
Yeah. Evidently, she had no idea what it was. No idea. But she was one of those, oh my God, one of those type. You know what I'm talking about? She was. All right, so what is this number? Let's do this. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? So, I know it's not going to let me move it, so I might as well just leave it right there. All right, so point 0, let's count how many it'd be. About 8 probably. 1, 2, 3, 4, 5, 6, 7, 8. 5, 7. All right, and we're going to learn something about South Carolina here in a minute. About 10 years ago, it might have been, I don't know if it was 10 years ago or not. Oh, Lord. Everybody's got to have a comedian, right? Anyway.
You know about that?
About what?
That song?
No, I don't know anything.
I don't get it.
Now, are y'all going to listen or y'all going to talk about the song? About 10 years ago, or whenever the lottery started, somebody can look it up when it started.
I got you.
South Carolina was hell-bent on not having the lottery. At the same time, everybody was fighting to keep poker machines. Yeah. That was the Marlboro Reds for the gambling industry. In other words, back a long time ago, people used to smoke a cigar or smoke a pipe at the end of a long day, and it was a treat. It was something, to do before they went to bed. 94. How long ago was that? 20 years ago. But along came the cigarette, and the cigarette was the crack cocaine for the tobacco industry. Well, the poker machines was the crack cocaine for the gambling industry. Everybody could play it, and it was cheap, and ignorant people tried to win a lot of money on it. I'm sorry if that hits home with somebody. If somebody knows somebody that plays them, they still are legal now, but you can see them in the stores. People still play them. And the store owners say, oh, we don't cash out. We don't cash out. Yeah, right. Whatever. But anyway, the gambling, that was, you would walk into a store and there would be, are you listening? There would be 5 or 6 poker machines and there'd be 5 or 6 people there, and usually their kids would be outside playing in the street or whatever, and they would be in there playing poker machines. And everybody was raising sin about those poker machines being legalized, taken away, but they were also fussing they didn't want the lottery. Why did South Carolina not want the lottery? Everybody's going to say, I'm wearing the Bible Belt. No, that was part of it.
Because they saw what it did to Florida. and I learned it yesterday.
What did it do with Florida?
Well, see, they used some of the taxes on it for like employing the government, the people and stuff.
Well, the government messes up everything, but I know what you're saying. In other words, they wasn't using the funds for what they said they were going to do. Well, South Carolina has been, because a lot of y'all are going to school on the South Carolina lottery. A lot of people, they call it some kind of scholarship or something, but basically it's lottery money. It's one of them, yeah. All right, so to make the long story short, the reason South Carolina did not want the lottery was because, what else is South Carolina famous for? Being last in what? So what are we in South Carolina? We're dumb, ignorant, what? Southerners. Alright? So we have all these people from the north coming down and saying, y'all don't need that lottery, y'all don't need that lottery because all of y'all are going to go out and spend all y'all's money and your kids are going to starve to death. And that's why a lot of people didn't want the lottery to come to South Carolina because, let's do this. Let's say that Bubba, he wants to win the lottery. Alright? Bubba wants to win the lottery, so he's going to go out instead of one ticket, he's going to go out and buy 100 tickets. Somebody calculate it for me. 175, 223, 510. Somebody calculate 100. It's going to move the decimal place 2 times. What? Yeah, it just moves it 10 times. So 7 would be 6. That's 6. So Bubba, chances have really gone up, hasn't it? No, because it's still 0, because we usually count to the 100th place.
Can't you only buy so many?
Well, this is in theory. I don't know. I don't know how many you can buy. I only buy 10. That's the only vote, and that's when I feel like it. And I got money in my pocket. All right, let's try. So Bubba goes back, and he says, well, I really want to win that lottery, so he buys 1,000 tickets. Well, when he buys 1,000, that's going to be 1,000 over that mess, which comes out to be, well, 1,000 is another, so that'd be 5 zeros. I'm just saying he buys 1,000. Just hold on a minute. Don't muddy the water, all right? 0, 0, 0, 5, 7. Just hold on a minute. You'll see what point I'm getting to. Then he goes back and buys 1,000,000. Well, I'm getting there. You're stealing my thunder. 1,000,000 over. Well, that's 6. Take 6 off of this one, and that gives you what? 1, 2, 3, 4, 5, 6. 0.0057. Or whatever it comes out to be. Somebody calculate it for me. All right, my question is this. How smart is Bubba? He's not very smart because he's still got what kind of a chance? He's still got a 0 chance of winning. And that's what people were worried about when the South Carolina lottery was, or when it was being formed. Everybody was scared that Bubba and Bubette was going to go out and spend all their money on lottery because we in South Carolina are dumb and what? Ignorant. Because we're last in education. And that's why a lot of the politicians were fighting it. They were saying that everybody's going to go out and spend their money. So what can you say about the lottery as far as buying 1 ticket or 1,000,000?
You got the same chance.
You got the same chance of winning if you buy 1 versus if you buy 1,000,000. And if you had $1 million, why would you buy 1,000,000 tickets when you already have $1 million in your pocket? I would. So what? It's making you think, ain't it?
I mean, it just killed my dream a little bit, but I mean, it's cool.
No, it's not. It wouldn't kill your dreams. You got the same chance of winning if you bought 1,000,000 or if you bought 1. Yes.
You still have a question as you want 100 first, then 1,000. Are you saying about 900 more? Or
It doesn't matter. It doesn't matter if you buy another more because what's the chance? The chance is what I'm saying. It doesn't matter. If you bought 999 more or 99 more here, and you bought 990 or whatever, subtract what you got. You're still going to end up with what? You're still going to end up with 0 until you get to about 2 million. And when you get to 2 million, you start to get 0.01111 or something like that. In other words, up to about $1 million, this guy has the same chance of winning as this guy. That's what I'm trying to show you.
That's to get all the numbers.
Say again?
That's to get all the numbers right.
Yeah, that's the winning. So you got a better chance of getting hit by a bus when you go out in this parking lot than you do winning the lottery.
Don't they pay like to get like a couple of the numbers right?
Yeah, like $5 or
And so I
something.
still got a chance to get some. Bro, that is more than
Yeah, you just spent $10 on the tickets and you're going to win $5. That's going downhill.
That's just $50 money I can get right now.
What's your question? I can't hear you.
Does the lottery place that makes the lottery tickets know where the winning ticket is?
It's all computer generated. They put how many winners they want in the computer. And then the computer spits out all these tickets. Okay? And then the ping pong balls, that determines who wins. They could have multiple winners. It all depends on the ping pong balls.
So is it comes where nobody wins?
Huh? Yes. And it keeps building and keeps building and keeps building. That's why they get up to 300 million.
Right, and then you watch on TV that night and they don't call
Or you take it to the store the next day and they shoot it with the laser and then they see if it's a winner or not.
It's not like already pre-
I was one that voted for it. I had no problem voting for it.
Well,
Because I don't have a thing that you can legislate morality. You can't. People are going to gamble whether the law says to gamble or not. All right.
It's done.
they go back to the negotiation.
So let's do another one. Oh, let's see if we were right. What is our odds and what is their odds?
And Mr. McClure, just so you know, we got 7 minutes.
I know. You'll be all right.
You can write a check for me?
Look at there. What was ours? It's a miracle. We got it right. Now to get 100,000, you got to hit 1 in 5 million. And that's all 5. That's the 5 numbers without the Powerball. Or the Powerball. 5. If you hit just the Powerball, you get $4.
Ain't anything will help right now. I'm trying to tell you that, man.
All right. All right, I want everybody today to write down today, because today's going to be a bonus day, okay? Go with your other bonus that's in my office. Today's bonus day, so write it down so I can remember. And that last week of class, we'll add it too. This will be a 10-point bonus today, because I was late. If I could ever find how to get to the... There we go. Don't ask any questions. You were here today, and I wasn't, so I'm on. That way, hopefully, the person that complains all the time is not going to complain.